All right, the last but not least is the difference quotient. Now, we are also probably going to spend some time in class on the difference quotient. It's kind of a big deal. All right, when you get into calculus, the difference quotient is kind of a big deal. For us, I'm just going to have you know it. So you just need to memorize this difference quotient. And here it is. F of x plus h minus f of x all over h. And this is because h is in that denominator where h does not equal 0. Now, for our intents and purposes right now, we're just going to manipulate this algebraically. Just, teaser alert here is coming at you. Next semester, when you get into calculus and we do this in terms of limits, because we're going to take the limit here, the difference quotient. When you do that with a limit, then that has a whole separate impact. For us, right now, all I really want you to do is just work on the algebraic manipulation so that whenever it turns into that with your limits, the algebra is not going to trip you up and you can learn your calculus, your limits that go with it. All right? But for right now, just stick with me. We're just going to say, hey, here's the difference quotient. Ah, that's awesome. There's a couple of goals associated with the difference quotient. Our goal here is to get rid of the h variable, that h variable in the denominator. So we're just going to work on our algebra. We're going to have some functions, and we're just going to get rid of that h in the denominator. We're going to simplify these down in order to be able to pull that off. That's our goal. All right? So let's do that. Here is example 5. And I'm not going to give you the difference quotient. You're going to have to know it. So you're going to have this memorized. Memorize that. Okay. We're going to let f of x equal x squared plus 1. We are going to find the difference quotient. F of x plus h minus f of x all over h. This is how this works. When you have, I'm going to scoot this up so we can see it better. When you have this x plus h here, you are subbing in x plus h into your function. So here I have my function. I am taking this x plus h and I'm subbing it in. Over here, I'm subtracting just straight up my function. I'm not doing anything else to it. It's just straight up the function. So here I have x plus h squared plus 1. This is my f of x plus h part, minus my actual function, which in this instance is x squared plus 1. Now look at this again. Notice I put parentheses around this because I'm subtracting. You have to subtract this whole thing, so you put those parentheses. There's nothing to do with that h. You just simply divide out by your h. The key to the difference quotient, which is why we're practicing it now while we are learning algebra, is the algebra. When you use the difference quotient with your calculus, there's nothing to it. It's super easy. All right? Limits are easy. So that's not the issue. The algebra is where we have to focus our attention. And that's why we're doing it now. We got this while we're in algebra class. So we're going to do the same thing right here. See how this is squared? We're going to square the first term, multiply the two terms together by 2, and then square the last term. X squared plus 2xh plus h squared. That's where we have x plus h squared gets us this trinomial. Then I add 1. Minus, and then distribute this negative sign to both terms. So we have negative x squared minus 1 all over h. This will always happen. Look, you can always get rid of that h, and you do that by simplifying this numerator. Negative x squared, positive x squared. Negative 1 positive 1. There's always going to be something that you can simplify and break down to be looking at. Now I have a 2xh plus h squared all over h. Well, what do you see? There's an h now in common in the numerator, right? So if you factor that out, the h in the numerator cancels out that h in the denominator. Now, I don't care if there's an x, 2x plus h. I don't care if there's an h left in the problem. That's totally cool, right? That's totally fine. There can be an h left in that problem. That's no big deal at all. It just cannot be in the denominator. That's the key. Get rid of that h in the denominator. The denominator there is the key. I don't care if there's an h left in it, just can't be in that denominator. All right? Let's practice some more of these because this is a big deal. Here we go. And it's really just the algebraic manipulation to go with it. Here's example 6. F of x is equal to a 2x squared minus 3x. All right? We want to find the difference quotient. So I have my difference quotient, f of x plus h minus f of x all over h. And we plug that in. 2 times x plus h squared minus 3 times x plus h. I'm getting it jammed up here. Right? That is my first part. So let's color code it just so that you can see. So my first part, f of x plus h, is this first part of f of x plus h. Just plugging in x plus h into that part. Then I'm going to subtract. Oops, I got the wrong color. Then I'm going to subtract just my f of x function. So which is 2x squared minus 3x. That whole thing is over h. So my subtracting my f of x part, this is subtracting that f of x part. All right? Plugging in the x plus h to my original function. It's a substitution, right? I'm plugging it in for that. Then I'm just subtracting out my regular function. Okay, let's do this thing. I have 2 times, if you notice that's squared, same thing that we had before, minus, if I distribute that 3, I get a negative 3x and a negative 3h. If we distribute this negative, so I'm distributing the negative 3, right? If we distribute that other negative, I get a negative 2x squared plus 3x. This is, of course, all over h. At this time, if you see something that you can cancel out, such as those 3 x's, you can go ahead and do that. All right? We need to put that first set together a little bit more here. So I get 2x squared plus 4x plus 2h minus 3h minus a 2x squared all over h. And then as there's, take a look here. 2x squared minus 2x squared. Oopsie daisy. I bet you guys are screaming at me right now, right? This should be a 2xh. So this is a 4xh. Oh no, you forgot your h. Thanks. I appreciate it. Okay. So now if I factor an h out of that numerator, I'm left with 4x plus 2 minus 3. Oh, those I could put together, couldn't I? Well, I wasn't paying a bit of attention. Well, for crying out loud in a bucket. I got to get my act together, don't I? Take that all over h. Take care of those. And now I end up with 4x minus 1. All right? Pretty cool, right? 4x minus 1. this looked weird. Man, I bet you guys are probably flipping your lid right now. So that is still an H there. Oh. Sorry. Do you see what just happened? And I can't stop the video. Once it gets started, I can't edit it and stop it. So that's the sucky part. So here we are. This, when I square that second term, I should have squared this, multiply these together by 2, and I have that. That's what happened there. Then, whenever I go to combine my like terms, or distribute this, and I've got this 4xh and this 2h squared, what's left over, I have an h here, an h squared, and an h. When you factor out that h, you're left with this 4x, and here you're left with that 2h. And then when you factor out the h, you just have the 3. The h's go, and I'm left with 4x plus 2h minus 3. That looks nicer to me. All right. I'm telling you, that's why we have a pencil. Did I not say on day 1, we will eventually make mistakes. So we need to make sure that we're looking ahead to that. When you have a composition of functions, just plug it in, right? Just keep plugging that in and working it out. Plugging it in and working it out for your difference quotient. All right. Keep practicing those and then working those difference quotients. We'll definitely talk about those in class tomorrow. All right.